Welcome to the MasterMINED Club, your ultimate gateway into the world of Bitcoin mining. Whether you're just starting out or looking to scale your operations, our vibrant community of like-minded enthusiasts is here to support you every step of the way. Join us for weekly sessions led by industry pros, where you'll exchange ideas, brainstorm strategies, and stay motivated on your mining journey. From heat management to site optimization, our monthly deep dives cover the technical know-how you need to succeed. And with access to our entire back catalog, you'll never miss a beat. But that's not all. Our members enjoy exclusive one-on-one sessions with veteran miners, plus direct access to special pre-sales and insider opportunities at Bitcoin Mining World. Ready to take your mining to the next level? Join the MasterMINED Club today and secure your spot in the future of Bitcoin mining. Visit bitcoinminingworld.com or scan the QR code now. And now back to the show.
Welcome to MasterMINED. I'm your host, Joel Thomas. In today's session, we're going to talk about how open source Bitcoin mining hardware gets built, shipped, and sustained with Ronald Vinyl. And you're going to learn how Bitcoin miners are designed, what type of expertise is actually required, the realities of monetizing open source, and some common mistakes people make when trying to build Bitcoin mining hardware. So before we jump into that, we have a deal at Bitcoin Mining World that we want to feature. We've got some used Antminer T21s, 190 terahash at $4.75 per terahash. So make sure you check out the Telegram, Scott's Deals. You can see the link right there. And you definitely want to jump on that awesome deal. So, Ronald, welcome. How are you today?
Doing well, Joel. How are you?
I am very stoked to be here today. So I want to jump right into it with you. So why don't you give everybody a quick 5-minute background and tell them about what you're doing?
Yeah. So I've been in mining for a while, been a huge enthusiast for Bitcoin, but never really worked in that space initially, other than some hobbyist home mining. So I had this startup, which we'll probably talk about later on in the MasterMIND webinar. But I had a startup. We ran out of runway. What do you do when your startup fails? You go get a day job. And so I got a job at Intel doing mundane stuff, working on networking equipment for data centers. And it just really wasn't all that fulfilling, but I really liked Bitcoin. So inside of Intel, they had a mailing list for Bitcoin enthusiasts. I, of course, joined that. Jump ahead 8 years into that career. And I saw an email come through that introduced the second generation Intel Bitcoin mining ASICs. I'm like, second generation? I even know there was a first generation, and I'm like Mr. Bitcoin at work. So I sent an email to the manager that had sent out that announcement. I said, what gives? I want to have some coffee with you and talk about this. So long story short, we spent like an hour and a half chatting about Bitcoin. At the end of it, he offered me a job on their team. And that year and a half was the best time I had at Intel, and got to meet all sorts of awesome people, work with amazing companies, and really got bit by the let's build stuff bug. And sadly, Intel shifted its priorities, refocused on its core competencies, and doubled down on CPUs and whatnot. And as a result, they shut down the Intel block scale team, and all of our ASICs were no longer going to be sold, and our team was laid off. So my former now vice president, when he was laid off, let everyone know that he was starting a consulting company for Bitcoin engineering work, and extended an offer to join him. So when my ticket came up and I walked out that door and dropped off my badge, I sent him a message. I'm like, I'm in. So ever since that, it's been a little bit over a year now. We've been doing Bitcoin consulting for engineering, treasury type advisory work, and even Bitcoin Lightning in education. So going all over the country, going to conferences, meeting, again, more cool engineering teams, and one of whom sponsored us to go to Nashville, same event next week. A year ago from next week was the Nashville Energy and Mining Summit. And at that event, Block their Bitcoin mining side is Proto. Proto announced they were donating 256,000 of the old Intel ASICs that I was actually part of selling to them, to the 256 Foundation for the purpose of being granted out for open source development. So of course I applied for a grant and was approved, and I now have 54,000 of my old ASICs that I had shipped out to Block sitting in my guest room, annoying my wife. Yeah, so
Just
now
54,000.
Yeah, 54,000 ASICs. And I'm like, all right, well, now I need to do something with that. All right, so that's kind of like that backstory. Well, what was I doing at the time? I've been teaching the My First Bitcoin curriculum at my son and wife's school where she teaches for 4 years now. And it's like a high school and middle school level introduction to Bitcoin. And it covers the economics. What is Austrian economics? How does Bitcoin work? How does mining work? How does Lightning work? All your basics. From macro to microeconomics, all the way through some of the more technical stuff, like what is SHA-256 algorithm. And I've worked with them for a long time. I really like their team, and I'm passionate about increasing Bitcoin education. Well, one of the chapters in this curriculum that's really pretty light is mining. There's just not a lot out there for it. And I thought, what better application of this grant that has to be used for open source than to build an educational miner, not just your regular BitAx, which are great. And I think they've inspired a lot of people to get into home mining, decentralize the hash rate, and learn more about how the process works. But what if we could get it into schools? What if we could make it a real STEM project and get that?
Can you explain what STEM is, Ronald?
Yeah. So at school, right, the students are being taught, you've got your science, you've got your math, you've got art, you have English or whatever language. STEM is science, technology, engineering, and math. And often it's actually extended to be STEAM, science, technology, engineering, art, and math. And STEM projects are this confluence of these different disciplines where you can really engage a student, because math is boring. We all know that. I hate math. And science is really dry. And then technology, they're so immersed in it, it's like background noise, right? And engineering isn't really accessible at the high school or middle school level most of the time, because engineering projects are a huge challenge. So the principle of STEM education is to take all these different disciplines, tie them all together into a way that really drives it home for the student, gets them excited about technology, and moves that generation into a much more productive mind space.
All right. So let's start with the big picture, Ron, and talk about what you've done and what you're doing here. So tell us about Satoshi Starter. What is it?
All right. So all of that led to the idea of the Satoshi Starter. So what if we took Bitcoin mining back to its first principles and then built it up in a way that's accessible, unlike any way before? So we started with the problem of, well, how do you get into Bitcoin mining? Your regular 100 terahash plus rigs are, 3-phase power. They're very loud. They generate an excessive amount of heat. And that problem has begun to be solved by BitAxes and BitAx-like devices, where they cut down the number of ASICs from 300 or more down to just 1 or maybe 8 if you're, feeling really edgy. And instead of a giant fan set, you've got 1 or 2 fans. Sometimes they're liquid cooled. And instead of a ton of heat, they generate next to no heat, or the heat's at a level where it's more like a space heater. Okay, well, that's great. But if you look at them, they're mostly black boxes. Yes, they're open source hardware. And yes, the software is open source, but that doesn't really mean anything to your average person. So let's break it down one more step. You take this open source hardware, can you make this at home? And we'll cover a lot of this in the next hour, but the answer is no. And we'll kind of get into, what's involved in making these. So what do we need to do so that you can have a classroom of high school students in El Salvador be able to come to school, sit down for a class period, and at the end of maybe 2 class periods, walk home with a Bitcoin miner that's handsome enough to put on their desk or on their bookcase and show off to their friends while potentially earning sats or, hoping to lotto mine that big block win. And that's where we started, right? This is the problem that we're trying to solve here is Bitcoin education at the engineering level. Like, get the kids with soldering irons in their hands, get them that experience, and help them to really understand the whole process. And it's got all these knock-on effects as well, because this is a STEM project. They're doing a lot of science, right? They're learning about resistance and what is that. They're doing technology, right? They're flashing the firmware, they're mining. This is all very good technology education. They're doing their engineering work. They've got to test their circuit and make sure everything worked. If it doesn't work, find out where the problem was. And then there's math, it's SHA-256. So we can touch on that, although it's not math heavy. And then from the art perspective, the Satoshi Starter, I partnered with Modeo Tech. He's actually a globally renowned PCB artist, and he's designing all the artwork for this. So this is something that it doesn't look nerdy when they're done with it. It's going to look good, and that's the goal.
That's super cool. So why now? Why is this the right moment for educational Bitcoin mining hardware?
So historically, Bitcoin mining was something you could do from home, and you could kind of learn about it. You had, even if you visit the Bitcoin mining museum at one of the conferences, or if you visit them down in Texas, they've got the little USB stick miners on display there. And you plug one of those into your computer and you're hashing. That's it. You install a program on your computer, you're good to go. And everything was a lot simpler then. Today, the logistics, in fact, in some of these other MasterMINED videos that you've seen probably, we've got oil and gas barons, and we've got huge electric companies, and we've got multi-megawatt sites. This isn't home mining compatible hardware. So the industry has moved away, not even all that slowly, from even being able to be run at home. And that is the solution that BitAxes are trying to solve. But I think we really need to take it one step further and take away the black box. Let's really open this up from the inside, show off what it is, and champion that. So why now? Well, I received 54,000 ASICs for free, but that's not even the main motivator. Yes, we've got these ASICs, and yes, there's a lot more of them out there, but the S19 is showing its age. It's not doing well. The S21, S23, future machines, right? Avalon's got hardware. Chain Reaction has new ASICs coming out. Auradine has new ASICs coming out. Proto showed off their rig. The industry continues to become more efficient. Well, these older, less efficient systems should still have utility. They are still able to hash. So I see a future where old hash boards from S19s and older generation hardware can be repurposed for educational uses. And we're starting to see that across the industry. Miners have this old hardware they need to find a way to make money off of and to get rid of without filling landfills. This is a viable option. And then what we're starting to see is some challenge to Bitmain's monopoly on hash rate. And the way that these companies are challenging them is through being a little bit more open. And so actually, these are Auradine ASICs that I'll be working with for building hardware around. You cannot buy this from Bitmain. They will not sell you chips on reels. They won't sell you chips in trays. They won't give you documentation for the chips that they do have if you manage to get them off their boards. The 256 Foundation and the Open Source Miners United have reverse engineered all the stuff that we have for BitAxes today. And some extremely talented engineers have sat there and decompiled stuff and hooked up probes and watched the traffic and done the nerdiest stuff you can imagine just to get BitAxes to work. And it all ought to be unnecessary, because with documentation in hand, you could just build stuff. Instead, we're stuck trying to read the minds of some engineer across the planet that does not want you to know how their black box works. So the future is starting to look more open, right? We've got Chain Reaction and Auradine and Proto championing this new approach. Well, this new approach means we're going to need talented engineers today that will understand how to work with these chips, how to read the documentation, so they could build, hashing toasters and hot water heaters, as we saw at CES. And
that thing looks awesome, by the way. I just blew out a hot water heater like 5 months ago, and of course it was like a couple of days out of warranty. That's always how it works. Like the warranty expires 3 days later, the thing breaks. You call the company, and I went through multiple water heaters, and I saw that. I was like, I'd rather be hashing and heating my home than paying for some piece of crap water heater that I know is going to break in 5 years anyway. So anyways, keep going.
I've got a 14-year-old. Like, go take a second shower today. Come on. You got home from school. You had PE and gym and all that. Just go take another shower. You know what? Take 3 showers. We got a lot of hot water to burn through so we can get some more mining done. Yeah. So I think that's really where I want to see things go. We don't have good education on the fundamentals of Bitcoin mining. And a lot of this we treat as like really hard math, which it is. And the hardware is extremely challenging, which it can be, but it can really be opened up with proper documentation and simplified models to start from.
I think one of the best opportunities for Bitcoin and spreading Bitcoin is education. I'll give you an example. I've got 3 kids, 10, 12, and 14 years old. And I just built a bit axe after mining disrupt with my son. And he's got these like little build-a-robot kits that he plays around with. But for me to sit down with him, because I'm trying to teach him all about Bitcoin so they understand what it is on like an instinctual level by the time they're older like us. And I think to myself, like, mining is such an important thing to teach because everybody, like, I'll give you an example. My wife, and I'm sure some of you might be able to relate to this. You come in, you're like, oh, Bitcoin, this and that. And they're like, oh, isn't that like a scam or something? Isn't the government? And when if you just watch this 20-second video of a mining tour and understand what Bitcoin is backed by on an industrial level, it changes your entire fundamental understanding of Bitcoin. So I think this is really, really, really amazing what you're doing, and it's an incredible opportunity. Do you think there's anything else missing from Bitcoin mining education today, or any good opportunities that this can help solve, aside from the obvious ones?
Yeah, actually, that's a good question, because I've been partnering with being in the Bitcoin education space, which is really niche, and then Bitcoin mining education, which is so much more niche. A lot of it currently is focused around hash board repair work, because that's where the money is, that's where the demand and needs are. Conventional ground up engineering of a new type of miner is left to larger companies who hire engineers who focus on that kind of engineering. But Dr. Michael Kelly, the Bitstorian on Telegram, he's doing a lot of educational work at Binghamton University in New York about Bitcoin, mostly from the economics perspective, but not just economics. So he's got this Bitcoin club that he started, and over time, it's really accumulated a lot of engineering acumen. And through that, I'm actually working with 2 of his former students in that, who are engineering majors in his Bitcoin club, who saw immediately, right, what they can apply their existing education skills to is Bitcoin mining. So one of them, Adi, he's working on a PCI Express, like a video card Bitcoin miner that you could stick in your computer. And actually, I talked at, blanked. Sorry, I taught Andy and I, his other student is Andy. We spoke at Mining Disrupt a couple months ago, and his innovation is to take Bitcoin mining ASICs and use them in 3D printers. So it's heating the bed. If you're familiar with 3D printing, your build area needs to be warm so the plastic adheres to it. So he's using ASICs to heat the print bed. And then the other aspect is you need your filament, the plastic you're printing with, to be dry and a little bit warmed. So he's using ASICs to heat the filament chamber to dry it out. Stuff you have to do anyway. I'm actually printing in the other room right now, and I have just electric coils burning electrons, not mining it. So what we say is that any form of resistant heating is actually a 0 terahash Bitcoin miner. Anytime you're running electricity through a coil and there's no compute on it, that's a 0 terahash Bitcoin miner that could be a miner. So these two engineers are working to kind of bring that. Well, Dr. Michael Kelly is pretty much the only person working in this space. And so when he heard about Satoshi Starter, he reached out to me. We've had several calls. And he's excited to use Satoshi Starter in his engineering classes because it involves the soldering, it involves the programming, it involves everything from the ground up. It's a very effective educational tool. Yeah, we'll get into it in a little bit, but the components in a BitAxe are not really conducive to education.
Very cool. All right, so let's dive into the nuts and bolts. So you want to build a miner, right? You're sitting here watching this, thinking about it. And I think a lot of people in Bitcoin say they want to build a miner in open source hardware. How hard can it be, right? So maybe I can just download the design off the internet and start building. So let's break down specifically what that means and start off at the top. Why don't you tell us about the components that are involved? And, like, where do we even start doing something like this?
Yeah, so there's really two different approaches you can take. The first one is I just want to download a file off the internet and through some sort of process end up with the ability to hold it in my hand. Like with the 3D printer example, I know I can download the model off of a website and put it in my software, hit print, and an hour later I'll have a cool toy to show off, or a doorstop. Right?
That's amazing.
This is what people think of when they think of home manufacturing today, is you take an open source design, you download it, and you hit print. Bitcoin mining is not quite that easy, and electronics manufacturing in general isn't there yet. The other aspect, right, is that you might say, I have an idea. I want to build a toaster that's heated with Bitcoin mining chips. I want to create. So let's focus on the easy approach first, which is I go to GitHub, I download the BitAxe repository, now what? And then we can kind of talk about what it takes to really truly innovate in this space once we've kind of covered some of these fundamentals. So you're starting a very long path when you make that decision. And having been down that path, it's expensive and time consuming and somewhat painful. So what do you need? Well, you need your design. We're going to steal one, right? This is all open source. They want you to take it. They want you to tinker with it and play with making changes. So I'm going to download the new BitAxe GT 800. I clone it to my desktop. Well, now I have a bunch of files that are unfamiliar to me. This is a bad place to start. If that's where you're at, building a miner from home is probably not for you just yet. And that's where a tool like the Satoshi Starter comes in, because it comes in kit form, and you don't have to learn a lot of these fundamentals. But when doing manufacturing of electronics, you need what are called Gerber files. And a Gerber file is basically a fancy picture that you send to a fabricator who's going to take that picture, and much like your 3D printer or a CNC, if you're familiar with that, they're going to drill that shape out of PCB material, the same thing that all circuit boards are made out of. As they're doing that, there's multiple layers. So a miner is like 8 layers of this drill, acid etch, deposit, until you get this sandwich. And your sandwich has raceways, right, of gold that are going to conduct electricity. They've got just regular PCB material that's going to be the foundation for the circuit. And then there's going to be a silk screen that tells you where everything goes on the top of that, a coating on top of that. And then once you've done that, you've waited about 3 weeks for this to be shipped off, the design to be sent to China and then shipped back to you. Or you're going to pay about 10 times more that cost and you're having it done in the United States, but you'll get it a lot faster. And often what you'll find at manufacturing is there's an immediate trade-off between getting something faster and getting it cheaper. You're not going to have both, most likely. But domestic manufacturing in particular can be extremely costly. Our cost of living is higher, our wages are higher, our expectations are different. So when you make these decisions like, well, this is going to be made in the USA, you have to be prepared that that's like a 10x increase in some of your core component costs. And some of it just won't be possible at any price point in the United States, unfortunately.
How do you even find somebody to manufacture? Maybe that's a new question, but I've never done this before. And if somebody like me wanted to do that, where would you start?
Yeah, so there's actually so there's two things. There's a great resource, Open Source Miners United. I think there's a link here that's been scrolling by. They have a brilliant Discord, and a lot of the engineers that work on the BitX that design it, Scott is in there, Duncan is in there. A lot of these people are in that chat, and they have a ton of experience that you can lean on. And that is the beauty of open source development, is that it is very communal. And as long as you're playing the game and you're participating and giving back, people will give you all sorts of support. So the software that is most commonly used for schematic design is KiCad. Originally developed for Linux, for the KDE environment, became very popular. Its biggest competitor, I feel, was Eagle, and then Autodesk bought Eagle, and they went all EA on it and closed it off. And as of, I think it is June of this year, they're not even going to make the free version available anymore. So we're seeing a lot of people just move to KiCad as the de facto standard for open source hardware development. And so you've got your software, you send off to a website that builds PCBs for for our first batch of Satoshi Starter hardware, we're using JLC PCB. They are not domestic, but they're very inexpensive. And at our point, we were able to pay for very rapid. So we got things very fast, and that's where we had to be. But domestically, there's a really great service called Oshpark, OSHPARK. And they are local, they're actually here in Oregon where I am, and they're famous for their purple PCBs. You'll see purple PCB products scattered around the open source ecosystem. Almost always, those are Oshpark PCBs. So it's like they're notable for them being purple instead of black or green or whatever you see under normal circumstances. And they're also great. I highly recommend that service. So that's like a service where you just upload a file, kind of like you would your 3D printer, but you don't have the machinery to do this at home. And then they send you back a board. Now you have a board. You either bought it off of eBay or you download the design and you sent it off and had it built. And this is kind of where, and I'll touch on this a little bit later, economies of scale really matter, because buying 2 boards is almost the same price as buying 25 boards. So you really don't want to do this halvesies. And this is a recurring theme that if you're going to do home manufacturing, there isn't really a way just to build a BitX without paying 30 times what you'd pay off of, Solo Satoshi or Pleb Source to buy one. Just it's night and day, right? You can't build one. In fact, there's several components that we had to buy for this. And when you add it to your cart, for the components you put on them, there's different websites. There's a website called Octopart, which helps you find the best price for parts. But the 2 largest ones are DigiKey and Mauser. There's also Newark, which is a large player. So you find the part you want. You build your you have a bill of materials. I'm getting out of my flow here. Sorry. So you download this schematic off of GitHub, you load it up, you send the image off to be fabricated while you're waiting for that to come back. Inside of it, it lists all the components that go on that board. And it gives that to you as a spreadsheet. You could throw that spreadsheet onto a different parts supplier website like DigiKey, and it'll try to find these parts. If the person who designed that board did a good job, it'll just find everything. Often it doesn't. And then you have to figure out what the substitute is. And that's where testing is going to come in, be very important later on. You won't always find exactly the part the original design called for. So now you got to do one of two things. Either you're going to find a substitute and then test and hope that the substitute does exactly what the previous part did, or you're going to redesign the board to accept a different part. Obviously, that increases the skill level requirements substantially. So you order all these parts. Well, if you order one of the parts, it's 8 cents. And if you order 10 of these parts, it's 7 cents. Like typically with some of these small capacitors and resistors, the price actually goes down when you order more than 10 because buying one just doesn't make sense. So you're going to buy their minimum order quantity to get the price down low. So you might as well build a few of these. In our case, we decided we're going to try to build 25. And we understand that we'll probably lose about half of them in our initial run of manufacturing as we iterate and make mistakes and have to make changes as we go. We had to substitute several parts. We can assume that some of our substitution choices were incorrect and that we'll have to make a change. And we just have the boards. We're going to keep going. And if we have to make a substantial change, there's a technique you call blue wiring, where you kind of bypass a circuit and hack your way through it. Otherwise, if it's too substantial of a change, we'll have to order more boards and wait again, which is the frustrating outcome we try our best to avoid. And you can try to avoid that by adding lots of test points all over your board. One of our early pitfalls in my former life was we designed this board, we thought it was perfect, sent it off, we got it back, it didn't work, and we didn't have any test points to check why it wasn't working. So we're sitting there with a little PCB, which is like almost like fiberglass, right? And a scalpel, and we're X-Acto knife, and we're trying to scrape down to get to the metal so we can shove a probe in there so we can see what's going on the inside. Real frustrating, not the sort of thing you want to do. So leave lots of test points when making your own design. And the bit axes are great about having test points scattered around where you're going to need them when something goes wrong. Scott does a really great job designing these. All right.
So are there any other?
Yeah.
Are there any other materials that you need?
So really all you need is the board and the parts and the ability to solder those parts onto the board. And again, this kind of comes to where the Satoshi Starter diverges from a bit axe. The bit axe is designed to be mass-produced and mass-produced at a low cost and efficiently. To achieve that, they went with very small components. So this is an example component. This is a, oh man, I don't even know what this is. I think it's a low dropout regulator or something. It's pretty big, right? This is workable. The ASICs are going to be one of your next bigger chips on the board. In fact, I have one of mine here. I taped it to a business card for scale. There's all my contact information. Too late. Anyway, so this is an Intel ASIC. And they're not big, but they're not super small. All right, now we get to the capacitors. And as I was telling Joel earlier, they're tiny. It's hard to express how tiny they are. So I saw a great picture on the internet. I could find it and post it later, I guess. But it's a Lego minifig. And next to his hand is a chip, more like what our ASICs are. And then it goes down in package sizes because you get these things in all sorts of different sizes. And it goes down to the second smallest component. And it's pretty small. It's like a dot on a page with a pen. And then the next component it shows is a piece of a granule of sugar. And then the next component it shows is the next package size down. These things are smaller than a grain of salt, just ridiculously tiny. I actually had some here. I was going to put on my finger, but there's no way you'll see it, right? It's dust. And heaven forbid you drop it, because it is so hard to find them. Our workspace is impeccably clean. And we worked from a reflective workspace, basically a piece of like a polished aluminum. So when we dropped a piece on it, we could see it, and use anti-static tweezers to pick it back up. Because if you use regular tweezers, it will stick to the tweezer. And if you try to touch it to your finger, it will stay stuck to your finger. These things are just so tiny. Well, you can't solder that with a soldering iron, of course. The process for mass production of circuit boards is reflow, typically. Well, what is that? You may be familiar with hand soldering a device where you have a wire, right, of solder, and you've got your little hot soldering iron, and you touch the iron to your component. You touch the solder to the component. The solder wire melts, wicks into the pin, and you remove the heat. It cools, and you form this beautiful peak junction that will conduct electricity and hold up to the rigors of, abuse of being moved around. We don't have that opportunity here. There are no holes in a bidax. I should have brought one up. If you'll notice, everything in it is all flat. Well, how do they achieve that? If you can't put a hole through, there's no pin. These are surface mount components. With surface mount components, your options are a little bit more limited. And then as the surface mount components get smaller, your options become more limited still. So some of the larger ones we can still hand solder, but it's a challenge. But for the smaller ones, it's not possible, because the component, like it sticks to the tweezers or your finger, would stick to a soldering iron. So we have a jig and a stencil, just like you would do to, put some graffiti on the side of a building. You put this stencil down above your board, perfectly laser cut out for the shape of your board. And you put what's known as solder paste onto your stencil. You have a squeegee. I mean, this is like if you've seen or ever made a t-shirt, you put the paint down, you squeegee it over your stencil, clamp it down, heat it up, and you're good to go. This is like that process. So you put down your solder paste, you squeegee across your stencil, you carefully lift your stencil up. All of your pads on your board now have solder. You have your set of components very nicely organized. You pick out each component. On some of these bidaxes, that's 76 components. And we went from 11 a.m. with breaks until 2 a.m. building our first prototype. Ridiculously complex and tedious. You lay down all these pieces, like a really complicated jigsaw puzzle, onto the pads in the correct orientation for some of them, until your whole board is populated with basically a damp metal paste that's got a little tiny grains of salt sticking to it. Well, now you have to... Your
solo Satoshi, does it require any soldering when people do these at home?
So we're going to have a couple of different kit options for the Satoshi Starter. We're going to have all the way from complete do-it-yourself, where you just get the board and the components and instructions, a classroom optimized kit where we are going to actually pre-solder the ASIC. It's hard to maybe make out, but this is the back. Oh, the camera's going to drift because it got confused. Sorry. So if you can make it out, if you'll focus. Can you see those pins?
Yeah, it's pretty clear.
So there are 64 of those pins, and they are underneath the chip. That's not something we expect a high school student can perform. So the kits going to the schools will have all the really complex parts pre-soldered. Rather than going with grains of sugar, we're going with much larger components, things that can be manipulated by unpracticed hands. And not using thermal solder paste, we're going to just use regular wire and soldering irons. So it's something that's much more approachable. And then the third option is a no soldering required kit, where it's just the assembly process, similar to what you did with the BitAxe, where you're installing the Raspberry Pi Pico, you're installing the heat sink, and you're programming it. And it's much more ready to mine than the other two kit options. Still comes with instructions, but far fewer steps.
Yeah, so I got two questions, and maybe give me like 60-second answers on these. Do you want to maybe talk about like the supply chain and sourcing realities? For example, maybe how do tariffs affect that? You've talked about some of the economies of scale, for example. Scaling.
I touched on some of that. Tariffs are now a reality, but having ordered a lot of parts, it's several $1,000s worth now, it's like less than 1%. Very few of the components are actually impacted by the tariffs, and the impact is low. It's like pennies sometimes on some of these orders. So they're real, but they're not a huge impact. These companies have been really creative about how they, move things to Vietnam or other countries that aren't as impacted by tariffs. It does make things take longer to receive, and some things arrive and they're like, well, you have to pay a tariff on this now, which makes delivery a little bit more complex. But overall, the supply chain has been really effective. You just have to keep in mind some of these issues. And then the fact that we're in the United States reduces a lot of the complexity because there's a lot of local stock. If you're in Europe or Latin America and you're trying to build a BitAxe from home, you're going to experience a lot more issues because they have value-added taxes added to these kinds of components, and there's import duties, and then things get seized because they don't know what they look like. And then you have to worry about customs. Working with another team, working on a different project, and they had a shipment go to Turkey, and it was just like chips like this, and customs held them for like 3 weeks. No reason either, just it looks suspicious and valuable, and we think you underdeclared it. And it's just ridiculous. So we're fortunate in the United States. Yes, we have tariffs, but we have a very reasonable customs process. We have no VAT. So it actually makes it a lot less expensive and a lot faster to manufacture here.
Okay. What about the documentation layer for this? So you had mentioned that, and I think that's one of the things that's difficult. So for example, I just built a node with my son after doing a BitAxe, and I'm watching this YouTube video and I'm going through it, and then I miss one little step, and I sit there for like 3 hours swearing at the table, trying to figure out why I can't get this thing to flash correctly, or it's not recognizing my USB drive, or all these things. What is the process of creating documentation? Because I think it's so important and probably something most people designing overlook. At least this is coming from a dad who has built 1,000 kids' toys and other things where every time I open the documentation, I'm like, I might as well just throw this out and start putting bolts on.
I think a lot of the Bitcoin community treats BTC sessions as our documentation. And we're like, he'll make a video about it. And coming from a long engineering background, I can say engineers are the wrong people to create documentation. And it's really an afterthought in most cases. In fact, we write software to auto-doc source code so we don't have to write the documentation for it. But it's essential, particularly if you're going to go into a classroom setting, and even more so when that classroom setting is not necessarily an English language classroom, but you're an English language engineer or engineering team. So our focus with this documentation effort for the Satoshi Starter was that it be accessible at a high school level, and that it not be English language specific, so that it's as approachable as possible. So we're actually taking a comic book format on the instruction guide, and we sat down with IKEA documentation and Lego manuals. And I don't know if you've, or maybe your wife has done Woobles, that crocheting kit, but they have excellent video documentation that walks you through another complex manufacturing process. How do you knit a little Harry Potter? Well, step one, you got your magic circle. This is not my space, so whatever that is, right? And then you do this ring, and you do this ring this way, and then you change it up that way. So these were our inspiration points for the documentation for the Satoshi Starter. And we wanted to make it so that it was visual and approachable and not really dependent on English heavily. So it's easy to translate the parts that have to be spelled out, but by and large is pictorial.
That's a lot of really good, great advice and some really good considerations. So let's move on to talking about some of the pitfalls and things like that. So going through this process, and obviously this is something you've been working on for a while, what do you think are some of the top pitfalls that somebody could run into if they want to take on an open source project like this?
Both I and my friend that's been helping me with this have an engineering background. We have a lot of engineering experience and friends and support in this space. We kind of know what we're doing. We made a lot of mistakes, even still, at having failed in the past as a startup building hardware. So what are some of the mistakes you can make? As I mentioned about test points and having to substitute parts, our parts all arrived, but we had two issues. One, I had missed a part in the bill of materials. It didn't have a part number populated the way it was supposed to, so I didn't order it. I did not double check. So then we're setting everything up. I posted a time lapse to my X account that's offline right now because X is awesome. And you can check it out later though. And we're going through all these little bags, and the bags have little tiny pieces of tape in them. And on that tape is this little dust thing. We're reading the part number, so you have to double check everything. Get through the list. Well, I'm missing this, this, and this. Well, one of them was a substitution, but we're pretty sure I made the wrong substitution. It's not going to work. And then the other one, we had missed ordering it. So I ordered it on Tuesday, but it won't be here for 24 days. And that's frustrating. It was a mistake that could have been addressed a month ago and wouldn't have been a problem at all, right? It would have arrived with all the other parts. Instead, we now kind of have this delay of one component. We could test a lot of the board still, but by missing a component, we're behind. And then we're manufacturing a BitX as our test point. We're not building the Satoshi Starter to begin with. We're testing our equipment and our expertise, and so we know what we're doing on an existing design. It's the BitX birds. It's still our ASICs. I've got 54,000 of them. I'm not buying anything from Bitmain. I'm going to use my chips. And it's a test design, right? Scott 9000 is still working on it. And we've been iterating. We've been reviewing it. We suggested changes because there's no documentation for other chips. We actually have the documentation for this. And we're working on publishing open source documentation so everyone in the world can have it. There's 256,000 of these chips out there, and still no public documentation. So Reckless Systems, we're creating the documentation for this from Intel's proprietary docs. We talked with Intel Legal. We got permission to adapt the proprietary confidential documentation into something that's open source that the community can use. So these chips don't just go to waste or have the need to be reverse engineered. So all that to say, we had no idea that some of these components were going to be just so small. And we had to change our build day approach when we saw that some of these, they're called 0402 components, were like almost impossible to work with. So we had to buy new anti-static tweezers and better lighting and pull-in lights. I've got this wand light here. We're like holding lights up, trying to see the board. And we had
awesome.
Lots of crazy magnification that we're not used to using. So know what you're biting off before you start. We saw everything, we bought everything, but you don't really know what you're getting into until it's sitting in front of you and you've got hands, right, that aren't steady enough to hold anything that still.
Okay, so in 60 seconds or less, Ronald, what would you maybe do different, or what surprised you the most about this project?
I think the biggest surprise were those component sizes. And then we borrowed a friend's reflow oven, and we have a great maker community here. And someone just had one because that's the crazy kind of nerd circles we run in. And we borrowed his oven, and we're testing it on, junk boards so we can see what the temperatures are like. That was a learning experience, having never done mass production. And it only fit 2 boards at a time, max. It was very small. It's like your toaster oven at home, or more like a toaster even, but very precise and very high temperature. And we ended up buying one ourselves. And through that build process, we didn't even get a chance to unbox ours. We just kept using the other one because it's very time consuming. Every step of this has taken so much more time than we had allocated for. So time allotment, and then really visualizing what you're doing before you begin.
It's great advice. Okay, I think we're going to do a Q&A here shortly, but before that, do you want to maybe touch on some resources quickly? For example, like open source repros, communities, tools, learning paths for students, how educators could maybe start, anything like that. If you want to give some advice, where can people find some great resources about this? I mean, aside from, we have a fantastic Telegram group that's dedicated to, building miners and things like that. So
yeah,
you can always check that out.
Telegram has some incredible resources. Yes, the Bitcoin Mining World Telegram channels, especially for the ASIC stuff, really, really helpful. The OSMU, the Open Source Miners United, they have a Discord that's, like I mentioned, very active and great for the real nitty gritty hardware nerd stuff. The 256 Foundation that ran the grant, they run Bitcoin Park. They're going to be running the National Energy and Mining Summit next week, a week from yesterday. Really great resource. That's where all these innovations really started to originate from and continues to be the source of the bulk of them. And then My First Bitcoin, I can't recommend highly enough. If you've got kids in like middle school to high school and you want them to get good Austrian economics education from the macro to the micro scale, as well as Bitcoin and how all of that works at a very approachable, age-appropriate way, get involved with My First Bitcoin. Find a cohort near you, or it's all open source. So you can download the PDF, buy the book on Amazon, and just talk with your kids about it. I think that's an investment well worth making. And then the Satoshi Starter, of course, if I can plug myself, we're live on Geyser, and Geyser's like a Kickstarter for Bitcoiners. It's Bitcoin only, but you can pay with a credit card. They're a very great team. You can back the Satoshi Starter today, and when we have gotten past the prototyping stage and we're shipping them, it's like $128, and it's a give one, get one program. So for every miner you purchase, we're going to send one to a school that's teaching the My First Bitcoin curriculum. Our goal is to get one to the entire cohort this year. There's 77 schools worldwide teaching it. I think there's 280 students. So we want to get one into every student's hand for 2026.
That's amazing. All right. Well, if anybody has questions in the chat, please drop them. I haven't seen anything come in yet. But in the meantime, if you want to get more involved, there is the Open Source Miners United. That's OSMU. They got a Discord, and that is https://osmu.xyz. So you can check that out. There is the 256 Foundation. That's Bitcoin Park and BitX work. That's 256foundation.org. There is the Bitcoin Mining World, of course. We have our Telegram channels, which we've talked about, and of course, My First Bitcoin. And also, I know you already said it, but you can find the Satoshi Starter at geyser.fund/projects/Satoshi Starter. Well, I don't see any other questions in here. So, Ronald, I want to thank you so much. I think what you're doing is fantastic. That's such a cool project. I definitely am going to pick one of these up when it's ready for my own kid to sit down with. And because I got 2 kids that are really into engineering, and I think this is just a great thing to do because 1, they get to learn about Bitcoin and how important it is to the world. 2, they get to do, oh, here we go. I got a question that just came in. Ronald, when do you use a reflow oven versus wave soldering?
Yeah, that's actually a good question. So wave soldering is where you have your PCBs all laid out on a tray, and then you have flow a wave of solder, liquid metal, over that board, and it sticks to the right spots, and then you place your components. Reflow soldering is where you take a cold board and you squeegee cold solder paste over it, through a stencil. You place your components, and then the final step is the same for both of them. You bake it, and then that melts the solder and really gets everything to stick. Wave soldering, because of the way it works, is really best for through-hole components. It's good for large production runs of things that have the hole going all the way through, so the solder can run through it. We use reflow soldering almost exclusively for surface mount components. The wave soldering would push the little grains of sand, right, components off as it flowed over it. It's not really well engineered for that. And then for like reflow soldering, there's then two more variants. There's infrared soldering, and then there's convection reflow. And what we are doing right now is infrared soldering. And for an example, that's like a $500 toaster oven, right, to do an IR reflow oven. And it's tiny, as I mentioned, only holds a few boards. Not at all for at-scale production. Whereas, that's like a pizza light. If you go into the pizzeria, they've got the pizza sitting out underneath the warming lights, and it's sitting there, and it's kind of hot in the middle, and the edges are kind of crusty, cold. It's not perfect. It's not even heating, but it's very inexpensive. Convection heating is like Gordon Ramsay or the Great British Bake Off. They say, set it to 50 fan or something, right? And it uses air. It's very gentle. It's extremely even. It's extremely precise. It's also extremely expensive. You don't buy convection reflow ovens for home use, even for hobbyists like us. When you're doing mass production, everything I've described, that's good for like 25, maybe 50 boards. When you want to do 500 boards, you're going to take your chips on reels and tape, and you're going to take your stack of PCBs that are all panelized. You're going to take them to a manufacturer that can do the entire panel at one time. They'll use convection reflow and a pick and place machine, not a person, and place everything that way. And then when you want to get up to like 5,000, and you're talking about like moving to China and doing real mass production where you're buying entire reels of components and you're spending thousands of dollars on just the bare hardware, the bare goods.
Awesome. Ronald, thank you so much for your time. Again, everybody, please check out Satoshi Starter at geyser.fun/project/Satoshi Starter. We're going to wrap up this mastermind. We will see you next time. And thank you so much for watching.
Thanks, Joel.
Thank you for joining us in the Mastermind Club, your ultimate gateway into the world of Bitcoin mining. Whether you're just starting out or looking to scale your operations, our vibrant community of like-minded enthusiasts is here to support you every step of the way. Join us next week where you'll exchange ideas, brainstorm strategies, and stay motivated on your mining journey. Thank you for joining us, and tune in next week.